Hello, my name is David Schultz. Welcome to Our Earth, its climate, history, and processes. In this lecture, I want to talk about what causes the motion of the plates that make up the surface of the Earth. Recall that mantle convection, the motions inside the mantle on geologic timescales, is what drives plate tectonics. I want to emphasize that the mantle is not a liquid, but it's solid, and it is the upwelling and downwelling of this buoyant, solid material over geologic time that drives the motion of the plates. The details of this are still under debate, but scientists are applying techniques and tools so that we can image the internal structure of the mantle and see these turbulent motions. In terms of what causes the plates to move, there are two forces that are believed to move the plates. One is called basal drag, and the other is called slab pull. Basal drag is the process by which friction between the mantle convection and the rigid plates transport the plates along the surface. So along the base, the mantle convective cell rises up and then hits the bottom of the lithosphere and then spreads out. And it's this spreading out, this horizontal motion that drives the basal drag. On the other hand, slab pull is the force applied as the plates descend into the mantle under their own weight. Remember that the crust is going to be much cooler than the asthenosphere that it's being drawn into, and that these ridges are also elevated relative to the trenches. So there is a slope to the crust as you go from the ridge into the trench where the plate is being subducted under the lithosphere. So what is the evidence for slab pull? We know that longer trenches are associated with plates that are being subducted more quickly than shorter trenches. In other words, the exposure of the trench to the surface of the Earth. And what this does is suggest that with the larger trench, with more of the plate being subducted, that there is greater gravitational pull of these plates being dragged down into the mantle. Whereas if you have a relatively small plate that's being subducted, there's less gravitational pull. So that evidence is consistent with the idea that slab pull is contributing. We already know that the spreading center, the mid-ocean ridge, is where new crust is being formed as magma comes up from below, cools and forms the new ocean crust. The question then is, where does this magma come from? It's not simply just mantle, because as we said before, the mantle is mostly solid. Even in the low velocity zone, where the upper mantle becomes partially melted, it's only about 1% melted. So we want to look at, in the next lecture, where this magma comes from.